All right, off to page 11, and I'm pretty excited because I think this is going to be my last video of the year. That's pretty exciting. So page 11, let's see how we can do on some of our area and surface area and volume and all that kind of fun stuff. So let's grab a pen here. So first thing is pretty simple shape. We've just got a little rectangle that has a right triangle sitting on top of it. I wish we had actually made markings on those, but we're running on a little bit of an assumption, which is really a little naughty. We should probably fix that. Same thing over here, that these are definitely right angles. So we should modify this review to say that. But anyway, if I know that this length is 16 and that length is 12, that means I've got a 4 here. And if this entire length here is 12 and this side is 9, that makes us 3. So we actually were trying to do something to be kind of nice to you in that. Because this triangle right here is a 3, 4, 5 triangle. Now we could do the Pythagorean theorem and say a squared plus b squared is c squared. But 9 and 16 makes 25. And so that's going to make c5. So finding the perimeter of this shape is going to be fairly simple because we're just going to have 12 plus 5 plus another 12 plus a 9 plus a 16. Oops, did I mess that up? Let's try that again. I got 12 for this entire side plus another 5 and a 12 and a 9 and a 16. Let's see, that adds up to more than I probably want to just do quickly in my head. I don't want to make any mistakes, but let's see. So we got 12 and 5 and 12 and 9 and 16. Looks like my perimeter should be around 54 feet. Now, we also want to find the area. Sorry about the music that's going on in the background. But the area of the main shape is going to be a rectangle, which of course is length times width or base times height. It'd be 16 by 9, which is 144. Plus we've got a triangle, which is 1/2 base times height. And so a half of 4 times 3 would be 6. So it looks like 150 square feet. Now, although those were very nice ones, this last one is a little harder. Waiting for the music to end. Okay, here we go. So if we have this slightly more complicated shape where we know this part is 6 and this is 11, that's going to make this missing little piece right here 5. Now, this is possibly one of those values that you wouldn't necessarily have memorized, but 25 and 144, that looks terrible. 144 makes 169, and the square root of 169 is 13. We actually made that number to be fairly nice. However, over here, if this is a 12 and a 13, this is only 1. So a squared plus b squared being c squared, that's 1 plus 36 is equal to c squared. That's going to make c the square root of 37. Well, that's going to make some of you feel a little bit uncomfortable, but that's just sort of what it is. So if we work our way around, our perimeter, we've got 13 to go all the way across, plus 11, and another 13, and then also a root 37. So if we added all those together up, I've got 13, 11, and 13. So I've got 37 plus the square root of 37. That's kind of an interesting coincidence there. But if you wanted to, we could actually type that in and say that that's about 43.08 inches. And of course, our area is going to be the area of the rectangle. And of course, this rectangle would be 12 by 6. Plus, this triangle up top here is a half of 5 by 12. And the triangle right here is 1/2 of 1 by 6. So 12 times 6 is 72. Let's see, 5 times 12 is 60. Half of that's 30. And half of 6 right here is 3. So we're looking at 102. So 105 inches squared. Cool. Kind of getting there. Number 47 shouldn't be too bad, surface area and volume. So of course, when I look at the surface area of this thing, I notice that there's a whole lot of simple shapes. We know that the base of this thing is a 3x4, which is, so we've got that 12, and we've got two of those. This side here is 4x5, which is 20, and of course, we've got two of those. And then this front face and the back face are 3x5, which is 15, and I've got, of course, two of those. So putting that all together, I've got a couple of 12s, which is 24, a couple of 20s, which is 40, and a couple of 15s, which is 30, and I got 94 centimeters squared. And of course, the volume is the area of the base times the height, but we already discussed how the area of that base is 12, height is 5. We're talking 60 centimeters cubed. Cool. All right. 47B, which probably is 49B, but we'll see. The surface area of a cylinder has two circles, which of course are both pi r squareds. Plus there is 2 pi r h, which is the circumference times the height. So 2 pi r squared plus 2 pi r and h. So let's see, what would that all give me? See, 144 times 2, because 12 squared is 144, so I got 288 pi. And over here, 2 times 12 times 7 is 168 pi. Add that to the 288, and we have 456 pi centimeters squared, which of course we could say it that way, or we could say is approximately 1,432.6 centimeters squared. Notice that I did the little approximate symbol. And of course, the volume is just the area of the base, which is pi r squared times the height. So that would be pi times 144, because the radius squared, times 7. So 144 times 7, we're talking 1,008 pi. Let's see, centimeters cubed, or of course, if we wanted to, 1,008 pi, we could say that's about 3,166.7 centimeters cubed. All right, making tracks. Letter D is going to be the easy one. Letter C is actually going to be the hard one. This one takes some time. So, okay, here we go. I'm going to start with a volume because I think that's the easy one. So the volume is 1/3 the area of the base times the height, but the base is just this nice little 8x5 story, which is 40, and the height is 9, and literally that's it. And of course, you could just do it. There's a number of ways that you could get that 120 that is sitting there, but a nice thing to do is notice that 3 goes into 9 3 times, and so 40 times 3 is 120. But if you wanted to multiply and divide, that's okay as well. Now, the reason I pause for the other one is my picture is going to start getting a little muddy, because when I look at this thing, I have to figure out the area of this triangular face that is sitting out here looking at me. And in order to find the area of that triangle, to find the surface area, I need to find its slant height. And it was not given to me. So if I know that this entire distance across here is 8, then that piece is 4, that's 9. So I could say 4 squared plus 9 squared is equal to the slant height squared. That'd be 16 and 36, which of course makes 52. So that makes the slant height right here the square root of 52. So the area of that triangle would be 1/2 its base, 5, times its slant height, 52, right? We also then have another triangle that is sitting right here. I'm going to call it the pink one. And I do realize that we're going to have 2 yellows and 2 pinks, one for the front and one for the back. But very much the same kind of story is that we're going to have this thing coming in here. So if this is 5, then that makes this value 2.5. So again, I could say that 2.5 squared plus 9 squared is equal to the other slant height squared. I'll call this slant height 1 and slant height 2. So let's see. 2.5 squared plus 9 squared is 8725. So that makes that slant height the square root of that. So the area of the other triangle is 1/2 its base, which is 8, times its slant height, which is 87.25 square rooted. So putting that all together, my surface area is going to be my base, which is 40, plus 2 of these triangles. But if I double this, I would just get 5 roots of 52 because I double it something that was cut in half and those would cancel out. And similarly, if I double this, because I have 2 of these, the 2 times a half would cancel out. And this is actually the final answer, and we could leave it that way, but most people are not going to feel super comfy with that strange looking answer. So we might as well get an approximation. 40 plus 5 square roots of 52 plus 8 square roots of 87.25. And we're looking at 150.78 meters. Again, area is always squared. And the very last problem of the year, the surface area of a sphere is always 4 pi r squared, and the volume is 4/3 pi r cubed. And so if we know that the radius is 9, 4 times pi times 9 squared, or 4/3 pi times 9 cubed. And let's see, 9 squared divided times 4 would be 324 pi. Let's see, inches squared, because it's surface area, volume is going to be cubed. So I'm going to have 9 cubed. I'm going to multiply that by 4 and divide by 3 for 4/3. And I got 972 pi inches cubed. And hey, we finished it up. Okay, thank you for joining me, and I hope this year has been a learning experience for you and you've got a bit out of geometry. And I will see you guys back in class. Bye-bye now.